Welcome to chemistry, guys. Today we're going to be taking stoichiometry, under which we have the following subtopics. What is chemical stoichiometry? Chemical stoichiometry can be defined as refers to the quantitative study of the reactants and products in a chemical reaction. This means we're trying to understand mathematically how everything in the equation relates to each other, under which we have empirical formula, molecular formula. Empirical formula is a formula with the lowest ratio. It is the simplest formula of a compound, whereas molecular formula is the actual formula of a compound. Let's take an example. A compound is composed of 52.14% carbon, 13.13% hydrogen, and 34.73% oxygen by mass. What is the empirical formula? A and B. If the molar mass of the compound is 138.204 gram per mole, what is the molecular formula? We convert to solve this. I broke it down into steps, so follow attentively. First of all, we convert the percentage to gram. 1 gram is equal to 1%. Therefore, after that, step 2, we convert grams into mole. For carbon, if 1 gram gives you 12 moles, 12 moles is the atomic mass of carbon. If 1 gram gives you 12 moles, how many mole would 52.14 gram give to you? Because multiply and we get 43.4 mole as the answer. We go on to hydrogen. If 1 gram of hydrogen gives you 1.008 mole, which is the atomic mass of hydrogen, how many mole would 13.13 gram give to you? Because multiply and we get 13.026 mole for the answer. We'll do the same thing for oxygen and we get 2.171 mole for oxygen. Now, step 2, divide each molar mass by the smallest mole, which in this case is oxygen. Divide each mole by the smallest mole, which in this case is oxygen, having a molar mass of 2.171. Therefore, we divide the molar mass of carbon, 4.34, over the molar mass of oxygen, 2.171, and we have a subscript of 2. We do the same for hydrogen, we get a subscript of 6, and the same for oxygen, we get a subscript of 1. Therefore, the empirical formula becomes C2, which is the subscript of 2, H6O1. This is the simplest ratio of a formula. Let's go on to part B. If the molar mass of the compound is 138.204 gram per mole, what is the molecular formula? Now, to get this, we find the molar mass of the empirical formula. Now, note, we have the molar mass of the actual formula. Remember, we have the molar mass of the actual formula, but we don't have the formula thereof. But we have the empirical formula. And we're going to use the empirical formula to find the molar mass of the empirical formula itself. Therefore, step 1, multiply by the subscript, which is 2 times C plus 6 times H plus 1 times O. Put the atomic mass for each element. This will give you 2 times 12.01 plus 6 times 1.008 plus 1 times 16. This will give us a molar mass of 46.068. This is the molar mass of the empirical formula. Therefore, we compare it with the molar mass of the actual formula, which we don't know, but which we're going to find. Therefore, to do that, we follow step 2. Divide the molar mass of the molar formula by the molar mass of the empirical formula. So remember, what we are looking for is the molar formula, which is the actual formula of the compound. Therefore, we're going to divide 138.204, which is the molar mass of the molar formula, over 46.068, which is the molar mass of the empirical formula. This gives us 3. This gives us 3. Multiply the subscript of the empirical formula by 3, which is 3 times 2, 3 times 6, 3 times 1. This gives us a formula of C6H18O3. This is the molecular formula, which is the actual formula of the compound. Let's move on to the next thing on our list. Okay, let's solve this example yourself. A compound contains 20.32 gram of carbon, 5.12 gram of hydrogen, 7.9 gram of nitrogen. What is the empirical formula? B. If the molar mass of the compound is 236.448 gram per mole, what is the molecular formula? So all compositions has been given in gram already. Remember the last example, we had to convert from percentage to gram, but this example has been given in gram, so there's no need for conversion. Then I left a tip there. Tip is the molar mass of nitrogen is 14.01 gram per mole. Therefore, you just need to follow all the process from the previous example and you will get an empirical formula of 63H9N1 and the molar formula of 612H36O4. So that's it. Let's go to limiting agent. These are also called limiting reactants. This is the first reactant that is used up in a reaction. When the limiting reactant is all used up, no more product can be formed and the reaction stops. We call it a limiting reactant because it limits how much of the product we can make. Yes, so limiting reactant is the first reactant that is used up in the chemical reaction. Therefore, every other reactant that remains in the chemical reaction, they are called excess reactant. This is the reactant that is left after the limiting agent is used up. So in the previous video, we took empirical and molecular formula, limiting agents, while in this video, we'll be taking percentage yield. Percentage yield. To get the percentage yield, we need to understand what a yield is. Yield is the amount of product gotten from a chemical reaction, which can be measured in grams or moles. This is divided into two. There are two types of yield. One is the actual yield. This is the yield we get when we carry out the reaction. Second is the theoretical yield. This is the yield we'd expect to get based on our calculations. For example, when we do a reaction, 2 grams of hydrogen to react with 16 grams of oxygen to give us 18 grams of water. This 18 grams is based on our calculation. This is what we're expected to get based on our calculation. Therefore, it is called our theoretical yield. But when we carried out this practical in the lab, we actually got 15 grams of water instead of 18 grams of water. Now, this is our actual yield. Some reasons why we might not make as much product as we calculated. There are many types of reasons, but I'm going to give you 3 basic reasons. Number 1, some reactants might not at all react. Therefore, if some reactant doesn't react, it's going to limit the amount or reduce the amount of product we'll get. Number 2, side reactions. This means reactants react to produce a different product than what we're expecting. Number 3, losing some products during reaction. They might float off or escape from the system. Let's take an example. Calculating percentage yield. Percentage yield tells us what percentage of the theoretical yield we got. The formula is given as actual yield over theoretical yield times 100%. Using our previous example, our previous reaction, 2 grams of hydrogen reacting with 16 grams of oxygen to give us 18 grams of water based on our calculation. This is our theoretical yield. But in actual sense, after carrying out the practical in the laboratory, we got 15 grams of water instead, which is our actual yield. Therefore, following the formula, we have 15 grams to be, which is our actual yield, over 18 grams times 100% to give us a percentage yield of 83.3%. So thank you so much guys for watching. I'll see you in the next video.